So before we move on, let's quickly recap on this t-test right here. That's a sample t-test that's given to you. We're comparing the heart rates of a group of normal males, those that have never experienced a heart attack, and those that have experienced a heart attack. The data set includes 11 males on each side for control and the experimental group or the recovered group, and then you calculate your A, B, and C values given the formulas that we have in the lab manual. You calculate your sigma, the standard deviation right here, and then you plug all of this into your formula right here, your T calculation. The T came out to be equal to 0.136. And if you use this formula, if you use a computer, then you'll get a slightly different number, but that's just because of rounding. So 0.136 versus 0.139. Either way, you're going to have to then go to the degree of freedom table, where you will take the smaller of your data sets. Now for us, it was 11 males in each group, so 11 is the N for N1 or N2. But if you have uneven groups, then you go with the smaller group and subtract 1. So let's say we had only 10 in one group and 11 in the other, and you would take 10 minus 1, which is 9, as your for the degree of freedom table. We have 11 minus 1 is 10, so we're going to take a look at the table, and we find that the degree of freedom for a sample size of 10 is the cutoff DF is 2.23, and then all we have to do is compare our calculated T to the cutoff, and if your calculated T is smaller than the cutoff, then there is no significant difference. If you calculated T is greater than the T value or the cutoff value in the table, then there is a significant difference. So in this case, clearly 0.136 is smaller than 2.23, and so therefore there's no significant difference. Okay, and I will give you a data set, and then you can have fun with some calculations yourself and figure this out. But let's do quickly one little exercise for the presentation of data. And so here the graphing, a little graphing exercise I'm going to walk you through. And so here you're given a data set, and so somebody's starting to exercise, and the heart rate is going up as they start exercising. They're starting out at time 0 with a heart rate of 60 beats per minute, and then it goes up as they're exercising, and it sort of stabilizes around a higher value. So how should we graph a data set like this? So first you need to think about what's going on the x-axis. So what is your independent variable? On the x-axis goes the timeline. So we're going to put, this is our x. Let me put this here. And the heart rate, which is dependent on time, the change per time there, that's going to be on our y-axis. Okay, so that answers questions 1 and 2. Describe the data trend. Is it linear? Well, it kind of looks linear at first. For every 2 minutes it goes up, the heart rate goes up by 10 beats per minute, but then it starts to stabilize, and here it's no longer going up by 10 every 2 minutes. So it does curve. And so what do we think is happening? Well, you've established a new normal basically. And so first you're increasing the heart rate until the new heart rate meets the demand of your muscle tissues for oxygen and nutrients, and then you can stabilize right around 120, 125 beats per minute until you stop exercising. And how should we graph this? So let's use the graph paper right here. I'm going to stop the recording real quick to not waste your time and just kind of put this into the data table here. So here it is. I labeled the x and the y-axis. So the x-axis is our timeline. Let me take this off here, it's kind of confusing. So the heart rate goes up here onto the y-axis, and the exercise time, that's your x-axis right here. And so we go from in 2-minute increments. I use 3 boxes for each 2 minutes, and then goes to 20 minutes. And then here's a heart rate. I put a break into the y-axis because just to maximize the space here, I guess. And so this is not linear. These 2 lines here denote that it's not linear on the bottom here. We're starting here with 16, and we go up for every 2 boxes 10 beats per minute, so all the way up to 125 on the heart rate. and of course that's your y-axis over here, your dependent variable. And you can see at first the increase in heart rate as you start exercising is linear, so it goes from 60 to 70 to 80 to 90 to 100 for every 2 minutes, 10 beats per minute increase. And then we start leveling off a little bit. Then it's only 5, another 5, and then it's 10 again. And then we reach our maximum, and then all of a sudden we start to sort of just fluctuate around that maximum. But this is clearly a linear representation of the data. We need a line graph for that because we have a continuous increase in heart rate. So there's a continuous change in heart rate per time. And so a line graph is always used when all the in-betweens exist. So even though we took a sample only every 2 minutes of the heart rate, but all of the in-betweens exist, and so you have a continual change, and that is best represented with a line graph. Now it's going to be your turn to do some math, and I'm going to give you, for experiment 1, I'm going to give you some sample data, and we're going to put this into a table, and then you get to calculate a t-test. So you need to perform a t-test to determine whether or not there's a significant difference in the height of male versus female students in the class. I'm going to give you sample data that I collected a couple years ago, and then let you process the data. So we're going to go all the way down here on the data report. First thing, and you should do this even though we're not going to have a real class data table, and I'm going to give you some data, but you should find out your height in centimeters. I'm going to give you an example. So for me, I'm 5'10". That means I'm 70 inches tall, and if I want to convert that into centimeters, then my height is 177.8 centimeters. We're going to round this to the nearest centimeter, so I am 178 centimeters tall. And if I would square that number, so let me do that, then that turns out to be 31,684 square centimeters. And if every student does that, and we record this on the class data table here on the board, which we normally would do in a real classroom setting, but we don't get to do this. So I'm going to give you a data set that's composed of 16 male and 16 female student heights. And again, to not waste your time, I'm just going to put the data in there for you and then let you work with this. Okay, so here is the raw data set as collected in our classroom a couple years ago. You can see the height of the male students, and we have 16 students here on this side. The height of the female students, also 16 samples here on this side. And now I'm going to enter the square of the data. So 188 square would go in this here, in this space. 183 centimeters squared will go on this side. And again, to save some time, I'm just gonna stop the recording and put the data in. Okay, so here is your class data table with the squares of the heights of the different students already filled in. So really all you needed was the heights of the male students and the height of the female students. The goal will be to see if there is a significant difference. And just to tie this in with the questions that we had yesterday about observations and data collection, all of that. So really the observation would be that, hey, on average, males tend to be taller than females, and then you need to collect data and to see if that is true. And you have this question: is that, is it really true that on average the males are taller than females? And so now you need to collect data and then do your statistical analysis. So you have two samples, a female and a male sample of a size 16 here in this case. And then you're comparing whether or not there is a significant difference between these two groups of students, a male group and a female group. And the answer you want to try to get is yes or no. There is a significant difference in the height of males versus females or not. So now, as I explained earlier, there are rules to the game. We need to have a P of 0.05, and so we need to have 95% confidence. And what we're saying, we also need to take a look at the variance. And so as you're processing this data set, next thing you need to do is first of all here calculate the sum of the data, so that's the total. That would be your A number. A equals the sum of the heights of the male students, the sum of the height of the female students. B is the sum of the squares, and you add up all the sum of the squares for the male students and the sum of the female students right here. So these would be fairly large numbers. The X bar, that is the sum divided by 16, which is n. So you want to have the average male height and the average female height. Those are your X bars right here. And then you want to calculate sigma, which is your standard deviation. And so for that, you need to first calculate C, which is this formula right here. You need to take the B, the sum of the squares of the data minus the square of the sums divided by your sample size. That will give you C, and then you take the square root of C divided by n minus 1. And that will give you the sigma, the one standard deviation. That would include 66.67% of your data, but you want to find 95% confidence, so you need to include more. That's 1.96 times sigma. And you do the same thing here on the female side. You calculate your average height, and then you calculate your C, which again is a comparison or subtraction basically of the sum of the squares minus the square of the sums divided by the sample size. That will give you C for the females, and then you can use that to calculate sigma for the females, which is the variance, the variation in the data basically. So you take the square root of the C divided by n minus 1. If you need to refresh your memory on the formulas, go to page 22 where you find everything. And then you do your calculations right here, and in the next recording I'm going to show you the answers here, but I would like you to try this yourself first. You can fill out this data table 2.2, so you already know that n for males is 16 and n for the females is also 16, so that's something we already know. And I'm going to give you some time to calculate the rest of this table, and then find the answer. What is your calculated T? That's what you want to know. T equals the degree of freedom is going to be 16 minus 1 is 15, and so we can take a look at the T table on Appendix B real quick. Here is your Appendix B T table. We want 95% confidence limits and 0.05% probability. So the P 0.05, and now we have our degree of freedom. That will be our T cutoff value. We have 16 samples in each group, and so the DF is 16 minus 1 in this case, so that will be 15. So our T cutoff value is at 2.13. And let's go back. So we have degree of freedom of 15, and our cutoff was 2.13 from the T table. Okay, so now you need to calculate all of these numbers: the A, the sum of the values, the average of the heights, and then the sum of the squares, calculate your C and your sigma, the standard deviation, and then calculate T with the formula, and then you should be answering T equals something, and then you need to compare. Is my calculated T larger or smaller than the cutoff value? If the T is larger than the cutoff value, then there is a significant difference between male and female height. If your calculated T is smaller than the cutoff of 2.13, then there is no significant difference between the height of males and females in the samples that we have. And you should be able to answer this question number 1 here, whether there is a significant difference between the two groups, yes or no. And you should also be able to explain which hypothesis was correct, with the null hypothesis always being the one that says no significant difference, and that would mean that your calculated T is less than the cutoff of 2.13. So anyway, please try your best to calculate this, and then once you're done with your own calculation, you can take a look at the next video that will explain the answers and give you the answers to these questions here.